Before we can get into the big formula, we need to learn a couple mathematical symbols if we didn't know them already. The first is the factorial symbol. Now, the factorial symbol is an exclamation point after a number. So what that means is that it's that number times itself. 4 times 3 times 2 times 1. So itself times itself minus 1, and so on. Now, luckily for you, we have Excel, and we're going to make Excel do a lot of this. So let's see, this is going to be example 4 up here. So we wanted to find 4 factorial. This was letter A, right? Oh, hold on one second. All right, there they are. I figured, why reinvent the wheel, right? Let's just copy and paste. Now, the good thing is, whoa, what the heck am I doing way down there? No idea. Okay, now the good news is that Excel knows this symbol. So you type equals 4 exclamation point, enter. Nope, didn't like it. Oh, it needs the factorial. That's right. F-A-C-T. There it is. I knew it was in here somewhere. There. 4 factorial. F-A-C-T is the combo for factorial. So equals F-A-C-T 7. And then equals F-A-C-T 10. There you go. Simple as that. Love it. Now, of course, if you didn't have Excel, I mean, it's too hard to do. I mean, you just grab your calculator. 4 times 3 times 2 times 1. 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on. Cool. Done with those. Matter of fact, I'm just going to copy and paste them in. Oh, you know what? Better make them bold. Underlined. That's good. Okay. Oops, I'm up here. Done. Simple as that. Just on a side note, real quick before we leave that, 0 factorial is equal to 1. That's just a definition. There's some reasons behind it, but I don't want to get into it right now. And then 1 factorial is equal to 1, obviously, because 1 times itself is 1. Okay. Now, the number of combinations of n distinct objects taken are at a time. So remember, we learned the multiplication rule way back in chapter 5, where you'd say like, oh, you know, I don't know, I have... If I'm going to draw, perfect. If I'm going to draw 2 cards with replacement, then the number of ways I can do that is 52 times 52, because it's with replacement. So we never really dealt with what do you do if it's not replaced, and that's what a combination does. The combination is, hey, I'm going to draw cards. I'm not going to replace them. This is the number of ways I can do it. And combinations in particular mean that they have no order, which is the way cards work, right? Cards are like, hey, it doesn't matter whether you dealt the ace first or the king first, it still counts as an ace and a king in a hand. All right, so I'm going to have to put these in Excel. Now, this isn't going to work as pretty because if I try to copy and paste, I'll show you what happens. I'm going to put it in the same spreadsheet. No need to separate these two. This is example 5, right? It comes in like that. It's really kind of funky. So I'm just going to do it this way. And then this one was... I better make this smaller so I can see what I'm doing. So this was 5C2. That's a pretty common way to abbreviate this stuff. Put the number before, and then C, and then the number after. And then, what was the last one? Oops. Oh, that same one. That can't be right. I'll have to fix that. Matter of fact, I did fix it. Alright, well, I'll put it right here. 17... C10. Let's just go for broke here. All right, there we go. Okay, so let me go back here and I'll type 17. This is C. 17C10. Just to kind of know. All right, now how do you do that with Excel? Well, Excel has a combination feature. So combination, get it? And then N is the number and then the number chosen. So it was 5. And I'm going to choose 5, choose 2. Enter. There you go. And this one's combination 7, 4. And this one's combination 17, 10. Once you fix that, I'll try to fix it before you guys get a hold of it. So there we go. Those 3 numbers are the 3 answers. Easy as that. Now, that one, of course, that'd be a lot harder to do on your own with just a calculator. I mean, you could do it. You could find the factorials and then put it over the other ones, but that's not likely to happen. Not on a test, at least. Not, you could have to do it on the mini test. That's totally possible. The online mini test. All right, let's move down here. We had our free throws, remember, the 77%. We had these probabilities, right? So remember, these were the probabilities, these were the number of successes, right? So how many successes are we seeing here with this? So this one is no successes, right? Oops, I'm going to paste this over here. 0 successes, right? Oh, excuse me, I have to take it back. It's all 3. Oops. I'm thinking of the bottom. The bottom is the no successes one, right? The fail, fail, fail part. That's 0 successes, which is way down here. That one will go with 0. All right, hold on, let me fill these in. There we go. I put them all in there. So this is 3 successes up here. This one is 2, 2. This one's 1. This one's 2 again, and so on, all the way down to 0. Now, what I wanted you to notice was how many of these outcomes contain 0 successes? Well, one of them does. Fail, 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 right there, right? So 1, fail, fail, fail. And just on a side note, 3, right? Because there's 3 players shooting, right? So 3, choose 0. What would that be? And let's go find it. Although I'll tell you right now it's 1. So equals combin 3, choose 0. Hey, look at that. Alana didn't lie to us, right? Matter of fact, I better put it over here and better remind myself what I was doing. This is example 6. So I guess this is going to be examples 4, 5, and 6 here. 4 and 5 and 6, at least a little bit. So this is 3, choose 0. Oh, and I better put out that this is example 6. Otherwise, we'll get all confused. So example 6. And if you'd like to make your life easier, it might help to color code this so you can keep the problem straight. So this was the first problem we had, right? And then, ooh, I don't like that color. It's like a gray. There we go. So that's the first problem. That's the second problem. Now we're on the third one. So 3, choose 0, we just found is 1. Interesting. Good to know. All right, now back here, how many outcomes contain 1 success? Okay, well, that was 3 of them, right? There was this one right here, SFF. Then there's this one right here, FSF. And then there's this one. So there's 3 of them. Now, for the fun of it, let's go find 3, choose 1. Oh, and I suppose this was part C. And now I'm in part E, which is 3, choose 1. So equals combin 3, 1. Interesting. 3. Yes, right. Noticing something? There were 3 players, and I'm choosing 1 to succeed. There are 3 ways I could do that, right? There are 3 players, I'm choosing none of them to succeed. There's only one way that could happen. Fail, fail, fail. Right? So what are you noticing, hopefully? That when you have this NCR thing, that's the way they described it to us. N is the number of objects you're drawing from, and R is how many successes you want, if you want to think of it that way, the number you're choosing, right? So when we do this, it doesn't have to be for binomial. This would work for all sorts of things. But if you do it this way, then N becomes the number of trials, and N is going to be, or excuse me, R is going to be the number of successes. And this number, this NCR number, will be the correct number of outcomes in a binomial experiment sample space with R successes from N trials. I should say N independent trials because it was a binomial experiment, though I suppose I don't have to say it, but I'll say it again. Not Tyrolls. I don't know what a Tyrol is, but trials. There we go. Well, that's fascinating because now we have the parts that we need to make this little distribution function work. So probability distribution function, P of x, is going to tell you the probability of x successes in n trials when the chances of success are p and the chances of failure are 1 minus p. All right? So notice the NCX business right there. That's how it works, right? Okay, so we're going to find this by hand and with Excel, I should say. By hand and with Excel. And I'm going to put by hands in quotes because we're not really going to do it by hand, but we're going to kind of show ourselves a little bit. So how would this work? Well, oops, go back. This is example 6 continued. So I'm actually going to put it, I think, over here somewhere. So for the first one, I want there. There we go. That way we can kind of look at it and kind of see. And of course, you don't have to put it here if you don't want it in columns E, F, and G. If you want to put down there, that's fine too. Just put it someplace that you know how to get to it. Okay? Okay, so how's this going to work? Well, according to the formula, I should be able to do it. Let's see here. I should be able to do 3 choose 0 times the probability of success, which was 0.77 to the 0 power, times the probability of failure, 0.23 to the 3rd power. Right? That's by hand if you're going to do it that way. Ugh, right? Okay, because, whoops, you don't need to say that. Hold on. There it is. That's what it's saying. It's saying, okay, look, we want 3 players, choose 0. I want the probability of success to be 0.77 to the 3rd, or excuse me, to the 0 power, because I want no successes. And then I want 3 failures. Ugh, what a giant pain. All right, so we're not going to do it that way. We're going to do it the Excel way. Yes? Yes. All right. So, I mean, if you wanted to, here, I'll show you. This will work. You just have to put combin in there, and then everything will be fine. So instead of 3C0, what you can do is you can say combin 3, 0 times 0.77 to the 0 times, matter of fact, I can even use it as a cell reference. Instead of saying to the 0, if I say to this, and then I say this is to the 3 minus that, right? What a mess. What a mess. Ah, but there's an easier way. Let me show you. It's binom dot dist. Or if you have old school Excel, it's just binom dist, like that. So binom dot dist or binom dist, depending. And then you tell it, okay, it wants to know how many successes do you want? Number success, number S. So I want 0. I'm going to use that cell reference right there, E2 in my example. Comma, I have 3 trials, right? Then it, comma, it wants to know the probability of success, which was 0.77, comma, cumulative, we're just going to take false. Close parentheses, enter. And it's the same thing. Look at that. No work involved. Beautiful, isn't it? And that's what we're going to put right in to our lovely table. As a matter of fact, I'm going to write it again. So I'm going to put 1 in right here, and I'm going to paste it. Oops, copy, paste, paste. This one would be 3. And of course, it used a cell reference anyway. Isn't that just tons easier than doing this awful formula with the combination thing and all of that? I mean, you can do it, but it ain't pretty. If you have Excel available, then have Excel help you out. I mean, it does all the heavy lifting. It knows that binom dist formula, right? Oh, it wasn't binom. It was binom dot dist. Sorry. Let me fix that. Okay, there they are. They're all fixed. Binom dot dist or binom dist, again, depending on your Excel. And then I went in and put them back in here. And then if you want to see the by hand formula, that's how you'd write it. 0.77 to the 0, 0.23 to the 3, 3C0. Or 3C1, 0.77 to the 1, 0.23 to the 2. Notice 1 and 2 add up to 3. And again down here, 3C2, 0.77 to the 2, 3C3, 0.77 to the 3, and so on. All right, we're all done with that question. I'll see you back here for the next page.